word of warning before you do your homework. These are some things you'll have to memorize. We haven't done many derivatives, most classes don't, of derivatives of inverse trig functions. You had to memorize the derivatives of them. This should be, say cosine, sorry. Cosine. The reason we only have 3 of these that you'll have to memorize is that if you had arc cosecant, it would just be the negative of this one. If you had arc secant, it would be the negative of this one, and arc cotangent, it would be the negative of this one. So I thought it might be good to refresh your memory for a minute, because you might run into this a little bit in your homework, to where you've got to recognize these derivatives. The derivative of arc sine of u is to say 1 over the square root of 1 minus u squared du. The derivative of arc tangent u is the nice little one, is 1 plus u squared du. And then the derivative of this one, arc secant, is the one that's longer. It's 1 over u times the square root of u squared minus a squared du. Had you memorize them a while back. Now what we've got to do is, when we run into them occasionally, we need to recognize them. Most of the time you'll recognize them is because the sub you're trying to do doesn't work, and maybe it's one of these. Okay, so let's look at this. So this is not a problem right now. We'll run into it in a minute. But say I'm taking the derivative of arc sine x over 3. That would be 1 over the square root of 1 minus u squared, and the derivative of that is 1/3. So I get 1 over 3, the square root of 1 minus x squared over 9. Like I talked about with some of you last week, you don't want to leave a fraction inside of a fraction, an improper fraction. So I'm getting a common denominator right there. That's 9 minus x squared over 9. So I get the square root of 9 minus x squared over, and the square root of this 9 is 3. So the answer is 1 over the square root of 9 minus x squared. All right, so now what happens if you have to integrate this? So let's try integrating 1 over the square root of 9 minus x squared dx. And I prefer to write my dx here instead of on top of that. I just think it makes it more clear for my students and myself. But you could write it on top of it. All right, now a lot of kids would like to make u sub 9 minus x squared, because this is too complicated to take the antiderivative of. But the problem is when you try u sub, you don't have an x up here for your dx. So that means u sub's not going to work. And so then you feel stuck because you actually couldn't integrate that one unless you recognize it as an arc sine. As an arc sine, I'm going to let u be a combination of this and my number, which is x over 3. The parts that are squared. So then I'm going to get du is 1/3 dx, gives me 3 du equals dx. Now let's sub in. I have 1 over the square root of 9 minus x squared. All right, so now I have to go up here and do something weird with x. So right here, and so the whole reason I'm doing this is I'm trying to get one of these inverse trig functions. It's weird looking at it at first, but you'll get used to it. So I'm going to say x is 3u. So now I've subbed in x squared is 9u squared. So I'm putting this in for x, 3u. So I get 9u squared, and dx is 3 du. So I have 3 times the integral of 1 over. I can take out this 9 and leave 1 minus u squared, and the square root of this 9 that I'm factoring out is 3. These cancel, and then you need to be able to recognize this. The antiderivative of that is arc sine of u plus c, and u was x over 3. However, if you recognize this from the beginning as an arc sine, okay, 1 over the square root of u squared minus a squared. You can go straight to this expression if you memorize these. Sorry, these. Okay, which I will make sure I give these to you explicitly. I'm not sure if they're in your packet or not. They're in your study guide. But if you recognize this, because if you just tried plain old u sub, you'd be stuck. You wouldn't have enough for substitution to work. But you can go straight to this, or whichever one that you have. Right now, it looks like an arc sign. So once you see it, you'll start thinking about it. So let's go back to this one that I did all of this work to. And let's say that I'm going to use this formula because I think, oh, I recognize that as an arc sign. So if you think it's an arctan, a is your number. This is a squared minus u squared. So a is whatever you think your number is that's being squared. In this case, we think 3 is being squared because we've got 9s in it. Arc sign doesn't have this extra 1 over a in front of it. So I'm going to say arc sign of u, which will be whatever we think is being squared, over a, which is our number, plus c. So I could go straight to arc sign of x over 3 plus c and get my answer, which we'll see in a little while. Okay, so just be patient, bear with me. All right, so let's do some of your homework problems. Let's do number 19. 19 is the integral of secant 2x tangent 2x dx. All right, so I'm going to let u be 2x. Now, what happens here is I'm writing this down is at first I might be a little bit distressed because I shouldn't have a product. But then I realized, oh, I know that antiderivative. That's why it's so important to intentionally do your homework, because the derivative of secant is secant tangent. It just has to be super simple. It has to be secant x tangent x, or secant a tangent a, or secant u tangent u. So I'm using u sub. So then I get du equals 2 dx, 1/2 du equals dx. If I had numbers, a definite integral instead of indefinite, I would fill these in and get new numbers. But I don't have that right now. It's an indefinite integral. So this gives me secant of 2x, tangent u, and dx is right here, 1/2 du is the way I work them. The antiderivative of secant tangent is secant u plus c. And if you never had numbers, you just go back to do that, and you have 1/2 2x. You don't have to check them, but you could if you wanted to, but I'm checking the answers. All right, now let's skip to, for a minute, number 23, and then we'll go back to 21. All right, 23, just for some consistency, 23 is 1 minus cosine t over 2 to the second power, and then you have sine of t over 2 dt. Your variables will always match up. All right, now that, of course, is way too complicated to take the antiderivative of. So we're going to try u sub as 1 minus cosine t over 2. du, the derivative of 1 is 0. The derivative of cosine is negative sine, which would make this positive. Sine of t over 2 times the derivative of t over 2, which is 1/2 dt. Those of you that have really been intentional in your homework up until now will be good at this. If you haven't been super intentional, you'll have to make sure that you are really good at your chain rule. Now I have 2u. What I like to do is get rid of my coefficient, and I get sine of t over 2 dt. So I have the integral of u squared. This sine is right here, gives me 2 du. So it makes it super simple. 2u cubed over 3 plus c. And I put u back in if I don't have limits of integration. And so that's my answer to 23. All right, now let's go to 21. Let's go back to 21. On 21, I have the integral of du over the square root of x squared plus 9. I'm sorry, just over x squared plus 9. I'll get it right in a minute. They have dx over x squared plus 9. It looks so innocent. I'm thinking I'm going to let u be x squared plus 9. Du is 2x dx. 1/2 du equals x dx. And then I realize there's a problem. There's a problem because I don't have an x anywhere. I'm looking for one. No extra x anywhere to use sub with. So this regular substitution didn't work. And the book suggests, the packet suggests, the page I copied suggests that you let u be x over 3. And you would justifiably go, okay, where did that come from? Which is 1/3 x. Let's just see what happens. I get 1/3 dx, so I get 3 du equals dx. So I have the integral of, this seems weird, dx is 3 du. All this other stuff is on the bottom, 1 over u squared. Okay, now that's weird. So let's change this. Let's multiply this side by 3u equals x. So I get x is 3u squared plus 3u squared plus 9. Wow, so I get 1 over 9u squared plus 9. So I factor out my 9, and I get 1/3. Sorry, I'm moving too fast probably. So I have 3 times the integral of 1 over 9 u squared plus 1 du. So I have 3 over 9, 1 over u squared plus 1 du. Then we're like, oh wait, I recognize that. It just still feels like we're stuck, but a long time ago you learned the derivative of tangent. Arctan was that. So that is arctan. So this gives me, after all that work, 1/3 arctan of u plus c. U was x over 3. So there's my answer for 21. But is there an easier way, a much easier way? So let's just erase this. Yeah, I would say I would give you the right to not even use substitution on this if you want to memorize the formula that always works. I just proved to you that it's going to work, but instead of all this work to get that answer, if I recognize this right here and I memorize these, I knew that I will get y'all to memorize these formulas when you run into things like this that you recognize. Now right now our A is our number 9, which meant that it was 3 squared equals 9, and u is just u. So I'm going to have to say this is a squared, this is 9. So I'm going to say 1 over the thing that you're squaring, which is 3, and then I'm going to have arctan of u over that. So what I'm saying is this would have been so much easier, and it's time for me to teach this to you now. So hopefully we'll get to where we recognize this as an arctan. So I'm going to say 1 over the number that's squared, arctan of this over this, u over a, plus c. Look at the answer. Same answer. Same answer. We'll work on that some. What I mean though is if you have the integral of like 1 over the square root of 16 minus x squared dx, u sub wouldn't work here. Like you could eventually get it probably with u sub if you did something with a fraction, but you do have the right now to go inverse sine of u over a plus c. If you memorize these, then you don't have to do all that substitution. This is, if you have, I'm sorry, I don't want that. The antiderivative of arc sine, I'll give these to you real neatly. arc sign is the one that doesn't have the 1 over a in front of it. Right now, with what number? With this being 16, our a is 4. And so that would be your answer to it instead of going through all the sub. So anyway, I know that's the first time you've seen that. We'll do that some more. Let's go straight into number 25. 25, so that we feel better about ourselves, is dx over this 1 minus x squared. All right, we have a composite function. So I'm going to let u be 1 minus x. Du is negative dx. So I get negative du equals dx. All right, so I have 1 over u squared. Dx is negative du. Like we talked about in class, this has nothing to do with ln. This is u to the negative 2 du. So I get negative u to the negative 1 over negative 1 plus c. That gives me, positive, because I have two negatives, 1 over u plus c. And without numbers, I just fill this back in. All right, number, let's see, let's do number 29. Is the integral of tan of 4x plus 2. That just means you will have had to have made sure you memorize the antiderivative of tan. U is 4x plus 2. Du is 4 dx. 1/4 du equals dx. So this is an integral of tangent u. Dx is 1/4 du. Antiderivative of tangent, you'll have to memorize, is ln. You can use either secant or negative cosine, either one that you like the best. I'll use negative cosine. Cosine u plus c. I don't leave myself enough room. So the antiderivative of tangent, you need to make sure you're memorizing them as you're doing your homework. You could have used negative 1. There was a 1/4 here already. Negative ln cosine, or you could have just used ln secant. Let's see. Let's do number 33. 33 is the integral of ln to the 6th x over x. Can't have a quotient, so I'm going to let u be ln x. Du is 1 over x dx. I can see how substitution is going to work, so I can go forward. This is u to the 6th, and everything else is 1 over x dx, which is du. So I get u to the 7th over 7 plus c, and I fill that back in.